We like to believe that the universe is controllable, that if we understand enough, measure enough, calculate enough, we can predict everything. The weather, the markets, the motion of stars, even human behavior. Knowledge feels like power, and power feels like control. For centuries, physics seemed to confirm this belief. Classical mechanics described a world that behaved like a clock. Every movement followed from a previous one. If the position and velocity of every particle were known, the future could be calculated. Nothing would surprise us. Nothing would escape prediction. The universe appeared mechanical, obedient, fully determined. Control seemed possible, but that image did not survive. As measurements became more precise, something subtle began to appear. Systems that should have been predictable were not. Small uncertainties grew larger. Tiny differences in initial conditions produced radically different outcomes. Even when laws were known perfectly, long-term prediction failed. This was not ignorance, it was instability. Chaos theory revealed that deterministic systems can be unpredictable in practice, not because they lack structure, but because they amplify small uncertainties beyond recovery. The equations remain intact. The behavior escapes control. The weather follows physical laws, yet it cannot be predicted indefinitely. This alone weakens the illusion. But physics goes further. At microscopic scales, predictability collapses completely. Quantum mechanics does not fail to predict outcomes. It refuses to. It predicts probabilities. It defines likelihoods. It constrains what can happen. But it does not determine what will happen. The future is not fully encoded in the present. Even with complete knowledge of a quantum system, the result of a measurement is not fixed. It is selected from allowed possibilities. There is structure, but no certainty. Constraint, but not inevitability. This changes everything. Control depends on predictability. Predictability depends on determinism. Determinism is not universal. At fundamental levels, reality contains irreducible uncertainty, and this uncertainty is not temporary. It is not the result of missing data. It is intrinsic to the structure of nature. The more precisely you measure a particle's position, the less precisely you can know its momentum. This is not a technical limitation. It is a boundary written into the fabric of physical law. Knowledge itself has limits. Control weakens further. Even outside quantum mechanics, large systems behave in ways that escape simple management. Complexity creates emergent behavior. New patterns arise that cannot be reduced to individual components. Control becomes distributed, not centralized. A star forms from gravity. A galaxy emerges from fluctuations. Life arises from chemistry. None of these processes are controlled in the way machines are controlled. They unfold within constraints, but without direction. The universe does not aim, it stabilizes. This is difficult to accept because it contradicts instinct. We evolve to seek agency. We look for causes, for forces, for drivers behind events. When we cannot find one, we invent one. Control feels necessary for order. Physics shows that order does not require control. Regularity emerges naturally when conditions allow it. Patterns stabilize because unstable configurations dissolve. The universe does not need supervision. It maintains coherence through consistency. Even gravity, which once felt like a pulling force exerted across distance, is simply geometry. Objects follow the curvature of space-time. No hand pushes them. No command directs them. They move because structure allows no alternative. Control is replaced by constraint, and constraint is quieter. This distinction becomes clearer when we look at large-scale cosmology. The expansion of the universe accelerates. Dark energy dominates cosmic evolution. Most of reality is invisible. We do not control these processes. We barely understand them. The universe unfolds regardless. Yet, this does not imply chaos in the everyday sense. Structures persist. Laws operate. Predictions work within limits. Planets orbit. Atoms remain stable. Stars burn for billions of years. There is reliability, but not control. Reliability emerges because constraints are consistent, not because events are commanded. This reframes how we think about power. Understanding physics does not grant authority over the universe. It reveals boundaries. It shows what cannot happen. It narrows possibility. It clarifies structure. But it does not provide dominance. Even the most advanced technology operates within physical limits. Energy cannot be created from nothing. Information cannot be destroyed without consequence. Speeds cannot exceed certain bounds. Every machine obeys constraints it cannot escape. Control, in physics, means working within limits, not eliminating them. At a deeper level, the illusion of control dissolves completely. The early universe evolved through fluctuations. Tiny variations in density expanded into galaxies. These fluctuations were random within constraints. They were not designed. They were not directed. And yet, from them, complexity emerged. You are the result of those fluctuations. The atoms in your body formed in stars that died long before Earth existed. The chemical pathways that sustain life evolved through selection, not planning. The neural activity that generates thought follows biochemical processes governed by physical law. There is structure everywhere. There is no central controller. This does not make existence meaningless. It makes it profound. Reality does not require control to remain coherent. It requires consistency. Patterns that align with constraints persist. Those that violate them disappear. Control is a human metaphor projected onto nature. Physics replaces it with something subtler. Stability through lawful interaction. When this is understood, fear of unpredictability softens. The universe is not chaotic in the sense of disorder. It is structured beyond complete access. There are boundaries to prediction, boundaries to knowledge, boundaries to influence. But within those boundaries, stability remains. The sun will rise tomorrow, not because someone ensures it, but because gravitational structure persists. Atoms will not randomly collapse, not because they are controlled, but because quantum constraints prevent it. Reality does not need supervision. It maintains itself. The illusion of control dissolves into respect for limits. And this is perhaps the most mature relationship physics offers. Not mastery over existence, not dominance over uncertainty, but participation within structure. We do not command the universe. We operate inside it. The deeper physics goes, the clearer this becomes. The universe is not something to be controlled. It is something to be understood, partially, conditionally, within limits. And that understanding is enough. Still, within